Okay, so our application problems, guys, are just doing what we've already been doing. Adding, subtracting, and multiplying polynomials. Okay, we just need to know when to do what operation. Okay, so this first says find the perimeter. What does perimeter mean? Distance around, but what do you do with your sides? Perimeter? You add them. Area is when we're going to multiply them, okay? So we're going to add all of our sides. Biggest mistakes I see, we have two sides labeled. We add these two sides together, and then we're done. Would that be the perimeter of my whole entire rectangle? No, so what do I need to do? I could multiply each by 2. I will say I think most people like just labeling each side. Since it's a rectangle, if the bottom is x plus 8, the top is also x plus 8. If the side is x plus 3, what's the other side? X plus 3. Do I now have all 4 sides labeled? Yeah, so now I'm ready to find my perimeter. So I'm going to do P for perimeter equals x plus 8, that's one side, plus what's another side? X plus 3, plus what's my other side? X plus 8, plus x plus 3. I have 1, 2, 3, 4 sides. My rectangle has 4 sides, so we're good. Okay? So, what operation are we doing here? Adding. Okay, so when we add, what are we looking for? When we add our like terms, what are we looking for? Say what? Say it a little louder. The same thing. The same thing. What do you mean, though, by the same thing? They look the same? How do they look the same? Do they have to have the same coefficient? I know you know what you're saying, but you had it correct with we have to have the same exponent. Okay? But what's the other piece that has to be the same? The constants don't have to be the same. The coefficients don't have to be the same. What is it, Michaela? The variable. So remember, the thing that makes like terms, same variable and the same variable's exponent. So I'm going to circle my like terms. I have an x here. Is there another like term with... we froze. Okay. Now we can see. There we go. Is there another like term with this x term? Are they all like terms? All the other x's. So plus x. Notice how I'm circling the operation sign in front of it. So it lets me know if I'm adding or subtracting my terms. Plus x, plus x. Do any of those x's have a coefficient written? No, so they all have an understood coefficient of 1. Good job. So I'm going to put 1s there just to help me. So what's 1x plus 1x? Plus 1x. Plus 1x. So I have 4 x's. Does that become x to the 4th? No, because when we add and subtract, exponents don't change. Okay? Now let's look at our constants. I have a plus 8. Is there a like term with my plus 8? Before that even, though. Plus 3, because all constants are like terms. So it's 8 plus 3. 11 plus 8. 19 plus 3. 22. So plus 22. So my perimeter equals 4x plus 22. Am I in the correct order? Yes. Are those like terms? No. An x term is not a like term with a constant. So we are done with our perimeter. On your quiz today, you will be adding terms, but then you also will be multiplying them. The biggest mistakes we make is not knowing when to do which operation, okay? What does the next part say? Find the area. What does area mean? Multiply. Am I going to multiply all four sides? Just length times width. And I'm going to put my sides in parentheses because I need to multiply the whole length by the whole width. Now, I taught y'all two different ways to multiply our, does anybody remember what this two-term polynomial is called? Binomial, good job. So my binomial times my binomial. What was the first way we learned? The box, the Punnett squares, okay? And then the other way was the double distribute, okay? Which way would y'all rather do it? Just the distribute. I think that's the way most of y'all like. If you want, draw the box, okay? So what is x times x? X squared. And how do I know, guys, just looking at the problem, how do I know I'm going to multiply these two parentheses together? Good job. There's not an addition or subtraction sign. When your parentheses are glued together, you are multiplying. And when we multiply, can exponents change? Yes, when we multiply, exponents change. When we add and subtract, they can't. Okay, so I get x squared. And then what's x times 3? 3x. Am I done distributing my x? Yep. What's 8 times x? And then last but not least, 8 times 3 is, what'd you say? 24. Good job. Drop down your a equals. So when we're multiplying, we first multiply, but then what operation are we doing? Adding or subtracting. Do I have like terms here? Yes. What are my like terms? Bless you. What's 3 plus 8? 11. So plus 11. Does it become x squared, guys? No. Drop down your x squared. Drop down your plus 24. And your area is equal to that. So again, today on your quiz, you are doing adding / subtracting, and then you're doing multiplying. Finding the area, this was an example of us adding like terms. And then did I say area? The perimeter was an example of adding like terms. The area is an example of multiplying. Okay? How do we feel about those? Do we see how it's basically stuff you've already learned? Yes. Okay, you just need to know some vocabulary. Next one. Read this for me, please, Ben. Very good. So this one's a little tricky. We want to find the area of the brick wall. What do you think we need to do? Multiply what, though? Because I have this small rectangle and I have this big rectangle. So I'm going to multiply the small rectangle. Is that going to give me, though, the area of the brick? No, that's the area of the pond. Okay? So what do we need to do? What do you think, Dylan?
Find the area of the pond, and then find the area of the brick and then subtract the total.
We're going to find the big area. But then we're going to subtract the area of the pond, because the pond doesn't have brick. And that's going to find the area in between. Okay, so this is like a three-parter. Find the big area, find the small area, and then we are going to subtract the two to find the middle area. So I'm going to say big area minus the small area, because the small area doesn't have brick, is going to equal my brick area. Can't see that, I'm zoomed in a little too much. Good? So, my big area, let's just worry about that right now. How can I find my big area, Monet? What sides? So tell me what they are. Tell me the expressions. Very good. And what are we going to do with those two sides? Say it again. But when you're finding area, do we add sides? We're going to multiply them. Very good. So I'm going to do 2x plus 4 times x plus 4. Don't worry about the small area right now. Let's just worry about the big area. Okay, let's simplify this. What am I going to do first? Heather, what am I going to do first?
Distribute.
What? 2 to the 1x. Very good. So what's 2x times 1x? So remember, when you multiply the coefficients. 2 times 1 is 2. When you're multiplying, 2 times 1 is 2. And then xx is x squared. So it's 2x squared. Okay, what am I going to do next, Leo?
You're going to multiply 2x times 4.
Great job. What is 2x times 4, Leo?
8x.
And it's a positive, so what needs to go in front of it?
Plus.
Plus 8x. Very good. Lexi, you with me? What do we do next, Lexi? Distribute the 4 to what? The x. What's 4 times x? Plus 4x. Great job. What do I do next, Marissa?
You do 4 times 4.
4 times 4, which is?
16.
16. Good job. Am I done distributing? Yes. What do I do next, Miles? Subtract it by what? The small area? Before I even do that, let's keep simplifying this. Is there anything I can do here to make it?
AX plus 4x.
Is what?
12x.
Very good. Combine your like terms. Drop down your 2x squared, drop down your plus 16. So is my big area now simplified, guys? Okay, so then I need to find my small area. How am I going to find my small area, Regina?
Multiply 2x.
Great job. The dimensions of my pond, the small area, is 2x times x. What do you get when you do 2x times x, Nicole? Say,
X squared.
what's my coefficient though? 2x squared. So I'm going to drop down my 2x squared. That becomes 2x squared. And what am I doing with these? Subtracting. Very good. Okay, what are we going to do next, Alex?
We're gonna take away, actually it's gonna cancel each other out. It's gonna number, so it'll just be 12x plus 16.
Great job. This 2x minus 2x cancels each other out. So Alex said we're left with 12x plus 16. And that's going to equal the brick area. So that one was a lot of steps, guys. We had to find 2 different areas and subtract them. So that was like a 3-parter. Are we good with that? Yep. Okay. Next, find volume. What's our volume formula, guys? Length, or I don't know what you said at first here. Height times length times width. I like to just put length times width times height. Same thing. So I have 3 dimensions to my rectangular prism. Okay, so volume equals 2x minus 1 times 3x plus 1 times x. How do we multiply 3 things? If I said, what is 2 times 3 times 4? How would you multiply those 3 numbers together?
You multiply 2 times
The product of those two. You would multiply by the last one. Good job. So I'm multiplying three things here. So I can't multiply all three at the same time. Just like Alex said, I'm going to multiply two of them, then multiply that answer, that product, by the third. So I'm going to pretend the x isn't even there. Okay? So I'm just going to multiply the two parentheses, the two first parentheses together first. So I'm going to get volume equals, what am I going to distribute first, Dominic? So if I'm pretending that one's not there.
2x
To what?
to the 3x.
And what do I get?
6x to the second power.
Great job. Ash, no. What am I going to do next? Before I move on to the negative, I still need to distribute the 2x to what? To the 1. So what's 2x times 1? 2x, positive 2x. Great job. What am I going to do next, Thomas?
Distribute the -1
To
3x.
very good. And what do you get?
-3x.
Great job. And then what's my last piece of distribution I need to do, Heidi? What's -1 times 1? -1. Very good. And I'm going to keep it in parentheses because I still need to multiply it by that x. Before we multiply it by that x, does anybody see something we can do? Combine like terms. What are my like terms here? 2x and what? -3x. What's 2x's minus 3x's? -1x. Do you need to put the 1? I'm not going to. Is it wrong if you do? No. And drop down your times x. We've never really done a problem where we have our long polynomial first and then just one term that we're multiplying at the end. Normally that one term is at the beginning, okay? But this is the same thing. We have three terms here that I need to multiply by this one term, okay? So I'm going to distribute. What is my 6x squared times x? 6x to the third. Very good, because when we multiply, exponents can change. What's -x times x? -x squared. Very good. And then what's -1 times x? Or just -x. Are any of these like terms? Nope. Are we in the correct order from big exponent down to small exponent? Yep. So we are done. How are we feeling, guys? Okay, so what are we doing today? We've done adding, we've done subtracting, we've done multiplying. Today we're going to do, it's even on the notes, guys. What are we doing today? Dividing, okay? I will tell you, I think the dividing ones are actually kind of the easiest ones. When a polynomial is divided by a monomial, again, what does the word monomial mean? One term. So when we're dividing by one term, all you do is you separate the polynomial and you simplify like factors. So this is kind of what we ended last semester with, okay? So again, this only works if the denominator is a monomial, okay? So one term in the denominator. So anytime I have a fraction, that's going to be the first thing I look at. Is my denominator only one term? Yes. So I can use this method. How many terms are in the numerator? 2. So how many times do I need to separate? 2. I'm going to make this one fraction into 2 fractions, okay? So I'm going to do 9y divided by 3. And then I'm going to do 12 divided by 3. Make your one fraction into 2 fractions. Then we're going to simplify each fraction by itself. So looking at my first fraction, what's 9y divided by 3, Bailey? 3y. 9 divided by 3 is 3, and then you just have your y. What's 12 divided by 3, Dylan Halverson? 4. And it's a positive, so I need to put a plus 4. Are these like terms? Nope. Done. That's it, guys. Do we like that? Yeah. Okay, next one. How many terms are in the denominator, Morgan?
4, or just 1?
Just one term. The term is 4. Okay. How many terms are in the numerator? 2. So how many fractions am I going to separate this into? 2 fractions. So I'm going to do 16a over 4. And then 20b over 4. So Yusra, what's 16a divided by 4? 4a, very good. And what's 20b over 4? I think I've called on everyone. What is it? 5b. And if it's a positive, what do I need to put? A plus, because that's what separates terms. Are those like terms? No. Done. Okay, so that's whenever that's when our denominator is just a constant. Now our denominator is going to have a variable in it. Same exact process, okay? How many terms are in the denominator, Marissa? 1. How many terms are in the numerator, Syra? In the numerator? 3. Very good. So I'm going to separate into 3 fractions. Each term in the numerator divided by the denominator. When I write my 18r squared, what needs to go in front of the 18, Dominic? I think that was someone else. But good job. And then I'm also going to put my negative 36r over negative 9r. So notice on the first two I didn't put the pluses because you don't need the plus if it's positive. Okay, whenever I separated my fractions I didn't put a plus. Okay, but if it was a negative I had to include the minus. Or if it was a minus I had to include the negative. So what's 27 divided by negative 9? Negative 3. How many r's are on top? 3. So 3 r's on top. How many on bottom? 1. Can you cancel a pair then? Yes. So then there's 2 left where? On top. So r squared. So what's negative 18 divided by negative 9? Negative, negative? Positive 2. You have 2 r's on top and r on bottom. Cancel and you have just r on top. Very good. And then what's negative 36 divided by negative 9? Positive 4. What happens with r over r? You have an r on top, r on bottom. You cancel. Do you have any r's left anywhere? No, they're all gone. Are any of these like terms? Nope. Done. Okay, number 4. How many terms do I have in the denominator, Morgan? In the denominator? Denominator's bottom. Just one term. How many terms do I have in the numerator, Morgan? 3. So how many fractions am I going to separate it into? 3 fractions. Make sure we're all doing this, guys. So 12p to the 4th over q, 12p to the 4th q over negative 2p squared q. Negative 18p to the 3rd q to the 2nd over negative 2p squared q. 18p squared q to the 3rd over negative 2p squared q. So this time I have 2 variables in each fraction. Okay? Again, this is going back to what we did at the end of last semester. Look just at your first fraction. Divide your coefficients first. Ben, what is this going to become? -6. Are there more p's on top or bottom? By how much? 2, so p squared, very good. Are there more q's on top or bottom? They're the same, so they cancel each other out. Good job. Alex, what's my second term going to become? Positive what? 9, very good. Are there more p's on top or bottom? Top. Very good. Very good. Do you need the exponents of 1? No. Good job. Regina, what's my last term going to become? Q what? To the second power. Good. Sorry, I thought I heard Q cubed. Q squared. Q to the second power. The p's cancel. You had 2 on top, 2 on bottom. Gone. Good? Are any of these like terms? No. There is your answer. Do we feel like we're ready to do one on our own? Yeah, I do. Okay, do number 5 on your own.